Today we are going to study about some special integrals. So we have some formulas here that if this type of function is there, then how to integrate that. We can just apply that formula there and integrate the function. So first of all, we have integral of dx upon x square minus a square. If the function is like this, so the integral is 1 upon 2a log x minus a upon x plus a plus c. So if we have the integral of this type, how do we integrate this? We can just apply the formula directly, 1 upon 2a log x minus a upon x plus a plus c. Then similarly we have some integrals, similar type of integrals are there. That is, if we have dx upon a square minus x square, then it is 1 upon 2a log a plus x upon a minus x plus c. After that, the third one is dx upon x square plus a square. So this is 1 upon a tan inverse x upon a plus c. Now, these are the three integrals. So we can say first set. Then the second set includes the integrals when we have an under root sign in the denominator. That is under root x square minus a square. 1 upon under root x square minus a square. So this is log x plus the same function which we have here, under root x square minus a square plus c. Then next one is 1 upon under root x square plus a square. Dx is there. Again log x plus the same function that we have here, the term we have here, x square plus a square plus c. And the next one is 1 upon under root a square minus x square. So this is sine inverse x upon a plus c. So this is, we can say 1, 2, 3 is first set in which we have 1 upon x square minus a square, 1 upon a square minus x square and 1 upon x square plus a square. And the second set has under root sign also. That is 1 upon under root x square minus a square, 1 upon under root x square plus a square and 1 upon under root a square minus x square. So basic these 6 formulas are there for special integrals, and continuation with these we have some formulas in which the form is not given there directly. So we have to convert it to this form. So what do we do in that? Let's take, if the integral is dx upon ax square plus bx plus c. Now it is not directly in any of these forms, but we look here, this function or this integral can be converted to either of the forms 1, 2 or 3 because it is without an under root sign. So what we will do, we will convert it to a perfect square. Convert to a perfect square. Right, this will be converted to a perfect square, and whatever form we have, so this integral will either be reduced to x square plus a square or x square minus a square, and then finally we can apply the formula. Now similarly, in continuation with this, we have another one which is in the form of under root ax square plus bx plus c. The same procedure we will apply here. We will again convert it to a perfect square and it will reduce to any of these integrals again in the form of under roots, and then again we can apply the formula. Right, now the other type is if the integral is given in the form of px plus q. Instead of 1 we are having some term here, px plus q upon ax square plus bx plus c. Now what to do here? We will write this as px plus q equal to a into derivative of the denominator plus b, right? We'll write it as a into derivative of denominator plus b, and then again we will determine a and b from here, and after that it will again be converted to any one of these 1, 2, 3 forms, and then we can finally find out the answer to this. And then we have again the same similar type with an under root here, that is px plus q upon under root ax square plus bx plus c, and same procedure we have to apply here, px plus q equal to a into derivative of the denominator. Denominator means only we will be taking here the term which is inside under root, that is ax square plus bx plus c plus b. And again using this equation we will find it will convert to both of them. This also and this also. It will convert to 2ax plus b, right? And using this equation we can find out the values of a and b, and putting the values of a and b, the integral will be divided into two parts. In one, some substitution will be applied, and in the other we will convert it to a perfect square. Similarly here, in one of this some substitution will be applied and the other will be converted to a perfect square. And perfect square, in case 9, the perfect square will be any of the forms of 1, 2, 3, and in 10th the perfect square will be any of the forms 4, 5, 6, and then we can again apply the formula accordingly. So these are some special integrals that we can do by looking at the question. If they are in any of these forms, so we can use these special integrals to solve those questions. So let's come to a question based on this. We are taking exercise 7.4, which is based on special integrals. And let's come to that. So we are taking, first of all, let's take a very simple question. That's question number 1. It is integral 3x square upon x raised power 6 plus 1 dx. So first of all, since we look here that it is not directly in the form of any of the integrals, so we have to convert it to any of the form. So for that, what we will do, let's just write it as, we can write it like this. This power can be adjusted and written like this, 3 to the 6, so x cube raised to the power 2. And let's put x cube equal to t. Put x cube equal to t, and we know whenever we are changing the variable in an integral, so we differentiate both sides with respect to the variables respectively. So this is 3x squared dx equal to dt. So the question converts to t. In place of 3x squared dx, we can put dt, and in place of x cube, it is t square plus 1. So we know the formula for this also, 1 upon 1 plus x square. It is the formula. The integral is tan inverse x, or if we take the special integrals, it is in the form of x square plus a square. Right? It is in the form of x square plus a square, that is 1 upon a tan inverse x upon a. So finally we again get that answer because a here is 1. So this is tan inverse t plus c. Constant of integration is very important. Now we can put the value of t here, that is tan inverse x cube plus c. So that is on the formula of 1 upon x square plus a square. Let's take another question. We are taking question number 4. This is 1 upon under root 9 minus 25x square. So first of all, we have to convert it to the form of the integral that we know. So the form is, we have to write it in the form under root a square, that is 3 square minus 5x whole square. Now it is in the form a square, 1 upon under root a square minus x square. So we can just compare it with the form 1 upon under root a square minus x square. So we'll apply the formulas of under root here. What is under root a square minus x square? That is sine inverse x upon a. X means the complete term which is here in place of x. Sine inverse x upon a. A is this term. But plus c. And one thing you should always remember when we are comparing it with a square minus x square. In place of x we have 5x here. So if in place of x, if in place of variable, any term, any other term is there, that is some constant is multiplied with that, divided by that, added with the variable or subtracted from the variable, we have to divide by the derivative of that, right? Because in place of x we are having 5x here, so we have to divide by the derivative of 5x. So derivative of 5x is 5, so we will divide by 5. So this is the final answer. Don't forget to divide by the variable, or divide by the term which is there in place of the variable. So this is how we have to compare it with the forms or of special integrals that we have learned, and we can apply the formulas and find out the results. And that's all for today. We'll continue the session tomorrow. Thank you and have a nice day.